Hello, everyone. Thank you for joining me today. My name is Juanita, and I'm going to be sharing some of the insights that I found when looking at some of the open source projects from the University of California system. So a little bit about me. I'm currently a PhD candidate at UC Santa Cruz. I work closely with the open source program office there, just because my research is mostly on open source security. But my background's actually in math, and I was the core developer for Spider IDE for a couple of years before starting my PhD. So I'm very involved with the Python community. I'm the communications chair for the SciPy conference, and I'm also the new chair of the new security track that we're launching for PyCon US next year. So submit your talks to the security track for PyCon US. So a little bit of background for the work that I'm going to be talking about today. This is part of an effort of building a network of open source program offices within the University of California system. This is composed by 6 universities right now, and the goal of this network is basically to promote sustainability and to help with open source best practices in academic settings. So the part of the work that I'm going to be talking about specifically focused on discovery. And basically, what we're trying to figure out is who is doing open source within the University of California system. So the first thing that I'm, of course, doing is building a database. I'm going to share a little bit about this, but this is not the main focus of my talk. I just kind of want to give you these for context on where the data that I'm going to be talking about comes from. So I collected a bunch of data using like campus keyword search and the GitHub's REST API. And I used some classification models with machine learning and LLMs, of course, to filter some of the noise from the search. So if you want to know a little bit more about how I'm building this database, I have a preprint that it's currently in review, but you can check it out online. But the data that I'm going to be talking about today comes from this search. So I was able to collect 52,000 repositories from the 10 universities of California, out of which around 50% of them are predicted to be affiliated with this University of California system. And while looking a little bit into some of these practices in open source of the projects from the UC system, I realized that we're not doing so great. So, I mean, it's clear that the README and the description have like very good usage, but apart from that, most of the rest of the practices are not very well. And if we look specifically about the security policy, this is very concerning because only 0.1% of the projects from the 25,000 that I found are actually using a security policy. So this made me think about, okay, so what else are we missing? So what I'm going to be talking about today is a little bit on like these analysis of security of some of these projects that I found. But the first thing that I wanted to do is figuring out, do we care about these projects? Are they actually important? My guess is yes, because a lot of the software that we use nowadays actually comes from academic research. So the first thing that I started looking into was this metric that the openness have developed called the criticality score. And this pretty much defines kind of the influence and importance of the projects based on different parameters and different weights. So it's basically a weighted sum of different parameters. And it gives you a number between 0 and 1, with 1 being the most critical. The 2 most important parameters for these criticality score are actually the contributor count and the dependence count. An asterisk on the dependence count, because this is kind of tricky to compute. They're using mentions to the project in commit messages of other projects to kind of associate this as dependence, but this is definitely not an easy metric to compute. And then the other thing that I put here was some of the scores for some projects that you might relate to. So, for example, Linux has a criticality score of 0.8, Chromium 0.7, NumPy 0.7, scikit-learn 0.74. If we look at the criticality score distribution for some of the projects of the UC system, so what I did is I took the top 2,000 by stars. And I did this because I wanted to filter out some of these smaller class projects that maybe students do for a class or that professors just have for their own assignments. So they're like not very used. Most of these projects have over 20 starts. And if we look at the distribution of the criticality score, we see that, yeah, they're not, like the average per se is not very critical. But there's a couple of projects that are above 0.5. And if we take into account that the Linux project has a criticality score of 0.8, that's actually pretty high. So one of the interesting things that I found is that a lot of these projects don't even have a license detected. And I write no license detected and not no license because I'm relying on GitHub's REST API to determine this, and sometimes it fails. However, when I looked at the top 10 projects with no license detected, 6 of them actually didn't have a license. And these projects have a criticality score that is higher than 0.4, which is half of the Linux project. So now, of course, I use scorecards to measure the security of the projects, because this is an amazing tool that also the OpenSSF is working on. And if you're not familiar with it, it just kind of runs a bunch of metrics in your repository, and it will give you scores for different metrics, and again, a weighted sum depending on the risk of each of the metrics. I'm not going to go too deep into each of them, but I just kind of wanted to say that they measure 3 main things: holistic security practices, source risk assessment, and build risk assessment. If we look at the scorecards distribution just of the kind of total score, this is what we get. And if you can see, it doesn't look very good, right? The mean of this score is about 2.5 for all these kind of 2,000 top star projects. And then the maximum for all of these projects is 6.7. But if you compare this with sort of state-of-the-art, so other projects that have done similar studies, we're not that bad, right? This is a paper that got published this year where they analyzed 3,248 research repositories that were actually peer-reviewed, and their average is actually 3.5. So not that much higher than us. And if you can see, most of the things that are above score of 6, they're actually outliers. So if we take a closer look into the actual metrics, we can see some of the averages from the scorecards metrics. And we can see that most of them actually have a very, very bad mean. And then some of the top ones have another problem, which is that a lot of the projects do not have a metric computed. So scorecards assigns a value of -1 for some of the projects where you can't compute the metric for whatever reason. And then if you see, packaging and dangerous workflow, which are actually the top scores that have the highest average, are also 2 of the ones where most of the values are actually -1. So there's very, very few projects where these metrics are actually computed. So the next thing I wanted to do was trying to figure out, well, are the projects actually getting better as their criticality increases? Because, I mean, yeah, intuitively, I should be better on my security practices as my project is more important for other people. And this is what I got. So this actually looks pretty good because it kind of shows that, in effect, the scorecard's total score is increasing as the criticality score also increases. It's not, not completely linear, but yeah, it shows some relation. So if we look at some of these kind of outlier projects here, I wanted to see what are the actual different metrics that are changing between some of the less critical projects, some of the less scorecard total score projects with the higher scores. So for example, projects 1 and 2 have very different scorecard score, but the criticality score is almost the same. And the same case with projects 3 and 4. So if I compute the difference between the metrics, each individual metric between 1 and 2 and then 3 and 4, I got this. So these are pretty much a bunch of numbers that represent subtractions between some of these projects. But what I wanted to point out is that there are 4 particular metrics that are actually changing between these projects. Binary artifacts, maintained, which basically measures kind of the amount of commits that a project has to figure out if it's maintained. CI tests, so if you run CI tests before merging PRs, and code review if you require human review before merging a PR. So I decided to go even deeper into analyzing how each of these metrics evolves as the criticality score changes. So this is kind of a heat map that shows how each of the metrics change per kind of different beans of criticality scores. And as you can see, most of the metrics are actually not changing that much. They're actually bad. The bottom part of that heat map will show you that they're not improving, but there are a couple of metrics that you can actually see an increase. This one's. So I removed the last column just because the last column has only like 2 projects, so the variability is too high to actually have some useful information. So if you only look at the first 5 columns, you actually do see that there are some metrics that are clearly improving as the criticality score increases. So license, contributors, CI tests, code review, branch protection, and dependency update tool. So if we look at specifically the amount of correlation between the scorecards metric and the criticality score, we see that most of them are positively correlated, with, for example, contributors being the highest metric correlated with the criticality score. But then there's a couple of them that have negative correlations. It's not very low, though. It's less than 0.1, but it's still negative correlated. But do you remember this? Most of these top metrics here actually have a lot of projects that don't even have these metrics computed. So this doesn't tell us that much about these particular metrics. What I do find interesting is that packaging and time release are also not correlated at all with the the criticality score. And if you see, these are actually only about 95 or 98% of the projects don't even have these metric, and they have -1. And if we look at the heat map for the packaging metric, all of the projects have actually a score of 10, and for the sign release, all of the projects have a score of 1. It doesn't of 0. Sorry, it doesn't matter where the criticality score lands. So after looking at this, I decided that not all of the metrics are that important in order to figure out whether these projects are secure or not. This is my personal humble opinion, of course. And by looking at some of these numbers and some of these graphs, I came up with 4 metrics that I think we should definitely pay more attention to. The first one is token permissions. Definitely, this is one of the highest risk metrics of scorecards, and I think this is something that we definitely want to improve the average on. The security policy is something that I think it's a lack of awareness mainly. A lot of projects maybe are not aware that this is something that they should be doing, but it's definitely something that it's not as easy, not as hard to implement, and it will make a difference on the project security as well. Static analysis is something that is not increasing as the criticality score increases, and I think this should be something that we should definitely be paying attention to. And finally, sign releases. We want to turn those zeros into 10s. So the next thing that I did, just because scorecards gave me some idea, but I wanted to look deeper into some of the characteristics of these projects. So I started doing contributor analysis. So if you're familiar with the XC attack, in my opinion, one of the main problems for these attacks was that there was only one maintainer taking care of a specific project. And that led to bullying and other people getting control of the project and making it completely unstable. So I started looking into these kind of very used concept called the bus factor. And in general, the bus factor in anything, not only software, is the amount of people that need to kind of get run over by a bus for the project to die or become unstable. In software particularly, and this is something that was defined by the chaos community, is the smallest number of contributors responsible for 60% of the total contributions. So I wanted to look at, in these projects that I'm talking about, how does the bus factor look like? And this is very scary, because 86% of the projects that I'm looking at have a bus factor of 1. So what this means is that if that one person gets run over by a bus, then 86% of the projects will probably die. So we also see that there's a couple of projects that do have a bigger bus factor. Yay, great for them. But in general, more than 95% of these projects actually have a bus factor between 1 and 2. Not very good. And the worst of all is that if we look at that compared to the criticality score, we don't really see that much change. Yes, there's a couple of projects that have a very high criticality score that have better bus factors, which is very good. But in general, a lot of the projects that have high criticality scores have very low bus factors. Okay, and the last thing that I want to show you, this is a sneak peek, because this is definitely a work in progress, but since I realized that static analysis is not very used among some of these projects, I was very curious about what I would find if I just run static analysis tools on some of these projects. So I picked the top 100 most critical projects just to make the analysis easier, and I started looking into some of these results. So it turns out that if you run SemGrep in 100 projects, you get more than 2,000 triggered rules. That's bad, right? Then I grouped them by the rules, so I didn't have like, I don't know, 2,000 from each of them. And these are kind of the number of repositories for each triggered rule. So as you can see, the most triggered rule is plain text HTTP link, which is actually something that is relatively easy to change. So what's the problem there? Is that, are they not aware that this is not the best practice? Or is it more like the project is inactive? And then the other two, which I think are interesting in terms of like the highest severity, are null library function and run shell injection. So shell injection specifically in GitHub Actions, and null library function using variables without verifying their null values. And some of these projects actually have a lot of these rules triggered. So I'm kind of questioning whether these, I mean, of course, one of the things that they should be doing is using static analysis so they could find some of these results and make some improvement. But this kind of shows me that this is probably a matter of education. I think that one of the goals that I'm trying to achieve is to help improve the security of academic open source. And I think one of the barriers is that a lot of the researchers that develop open source are not necessarily security experts. So this happens, right? There's a lot of probably minor code changes that could make the code a lot more secure, and they're just not aware of it. So what's next? So all of these findings are super interesting, but I need to do something about it, right? Because I can't just sit on the numbers and wait for them to change. So we have already built a lot of relationships with the open source projects from the University of California system. And I mean, I'm planning to reach out to them and share with them some of the findings from each of the projects, maybe open a few PRs and figure out if I can help them with some minor changes to make their code more secure. The second thing that I want to say is I think education is key, and I think it's one of the main limitations in research software. I think a lot of the people, especially people that don't have background in software, they're scientists, they're biologists, they're mathematicians, who are building tools because they need to, and they're just coding. And they don't necessarily have the expertise in security to do the best practices. And I honestly don't think that we need to wait until a project reaches 1 million stars in GitHub or becomes very popular to start thinking about security. I think we need to start thinking about security from the start. And because of that, I think that the open source program office, one of the things that we can do is provide some education on very basic things that projects can do differently to improve their security. And then all of these graphs and all of these plots also made me think about Do we need other metrics? Do we need better metrics? Some of the metrics that I showed you from scorecards, for example, do not give that much information about the security. So what do we need? And this is where I'm going to say, I need your help. I am definitely not an expert in security. I've learned a lot about along the way. But my goal here is to help improve the academic open source. And I am very open to any feedback or any ideas on how to do all of these things. It's going to be a long road, but I'm hoping that with the support of the open source program offices, we're going to make a change on some of these projects. Thank you. And I have about 5 minutes for questions. So there's a microphone in the center of the room if you want to ask a question. If you're too intimidated to go to the center of the room, you can also yell it, and I'll just repeat it for the recording. And I'll also leave my email in case you want to reach out and talk more about this, and also the website for the UC OSPO network, where we have some of the latest updates.
Hey there. So I guess is one takeaway that academia is not doing that much worse than industry? I guess, well, two questions. One is academia not doing that much worse than industry? And do you know, are there things that are like differentiators? So you pointed to some key metrics, but it seems like maybe, like sign releases, industry projects hopefully are doing that, and academics are not. Are there like key differences that you've noticed, I guess?
I think one of the maybe key differences that I can think about is the amount of people that are involved in a project. I think research projects in general are maybe developed by a few, like a group of very few students who are working on something. And I think that usually they don't necessarily have the support of companies or of other people externally who are looking at their projects. And I think my guess is that that's kind of like the key difference with industry, where there's a lot of people who are using a particular project, so they're interested in that. I think there is maybe like a line, a very blurry line, when an academic project that is developed at a university becomes an industry project. Jupyter, for example, came from Berkeley, and now it's used by a bunch of people, and now there's a whole lot of companies who are invested on it. There's a very blurry line between when something was academic and something is industry, but I think the amount of people involved and kind of pushing for better practices is, I would say, the key difference.
I don't know. I had one more question follow on. Does somebody else have a question? I don't know. So I guess how do you increase the bus factor? I guess that would be my last question.
Yeah. So if you remember, one of the first plots that I showed you was related not to security practices, but just to open source practices in general. So a lot of these people don't even have contributing guides. And my guess is that a minor increase on some of these practices will make a difference and will maybe make some people contribute to these projects and stay. The other thing that I want to say that we are doing, which is a little bit related to that, is we're actually building a showcase website where we have sort of a smaller database with some of these projects. We're reaching out to them so that they are aware that we're putting them in a website saying these are projects developed by the University of California system. But what we're hoping is that this will help kind of raise awareness on the things that are happening, and people will try to get involved with them and contribute to the projects, and hopefully not duplicate efforts, because a lot of what happens is that there's 20 different groups of people doing the same tool, and instead it will be better if they will combine together and build the same tool and make it better. So those are some ideas. But that's definitely one of the biggest challenges.
So Justin Kapos, NYU. One of the things we found really helpful with a lot of this is that there's effectively like a template repo that we can clone that has like sane default code of conduct, has sane defaults for issue templates and contributing guides and all the other things that are missing here. So I think if you want to get those numbers up, making that same template and then just going to the projects and opening a pull request on them, which you could do in an automated way to say, here, you seem to be missing these things. Here's what we would recommend you do. Just a thought.
Yeah, thank you. That sounds like a great idea. I will definitely start looking into that. I think we're out of time, but thank you so much for listening to me. And if you have more ideas or more questions, feel free to reach out.